Already in the last class, we have seen few problems in bilinear transformation. Let's see this problem. Find the bilinear transformation that maps 1 I minus 1 to I 0 minus I. So the points Z1, Z2, Z3 are given and W1, W2, W3 are given. So first we are going to use the cross ratio formula W minus W1 into W2 minus W3 divided by W1 minus W2 into W3 minus W is equal to Z minus Z1, Z2 minus Z3 divided by Z1 minus Z2 into Z3 minus Z. Memorize the coefficients in such a way that it starts with W, ends with W. Leftover terms W1, 2, 3. 1, 2, 3. This is the order. So now we are going to substitute the values. So W1 is I. So W minus I into W2 minus W3. What is the value of W2? 0 minus minus I. So 0 plus I divided by W1 minus W2. I minus 0 into W3 minus W. W3 is minus I minus W. Same way, we are going to substitute Z minus Z1, that is 1, into Z2 minus Z3. Z2 is I minus Z3 is minus I minus minus I, next step it will become I plus 1. Okay, and in the denominator Z1 minus Z2, that is 1 minus I into Z3 minus Z, minus 1 minus Z. Just we have substituted the points. So here please note carefully, if you want, okay, after simplification you can just cross multiply and start segregating the terms. So 0 plus I is I, and then denominator you have I. From minus I minus W I have taken minus common, so it will become W plus I, and right hand side we have these two terms here. Minus 1 minus Z, if you take minus common it will become Z plus 1. That minus I am multiplying it here, so 1 minus I will become I minus 1. Why we are doing it? Because if more negative terms are there, it's tough for us to multiply. So take out the negative term and then make it easy to simplify. If you want, you can keep as it is and just cross multiply, more than enough. But here the problem is, when you cross multiply you will get three terms, right? First is W minus I into Z plus 1 into I minus 1. You have to be extremely careful when you are doing the cross multiplication. So if you want, again I repeat, you can do the cross multiplication, that is multiply this with this and this with this. Okay, so on both the sides you will be having three terms. Multiply all the terms, segregate W to one side, Z to other side, and finish the problem. Okay, so that is one way. If you feel that okay, too many terms are there, then you can use these tricks also, multiply and divide by the complex conjugate. Okay, so for example, I minus 1 is there, so multiply and divide by I plus 1. Why we have to do like this? So if I multiply and divide by I plus 1, this term will become I plus 1 the whole square into Z minus 1 divided by I minus 1 into I plus 1 into Z plus 1. So this is A plus B the whole square, I square plus 1. I square value is minus 1, so this and this will get cancelled. Plus 2AB, 2I. Okay, leftover term is into Z minus 1 divided by A plus B into A minus B here. That is A square minus B square. So the denominator will become minus 2. So numerator you have minus 2I, denominator you have minus 2. This numerator and denominator, this will get cancelled, and you will be having, and also 2 also will get cancelled, and you will be having Z minus 1 by Z plus 1. Now if you cross multiply, it's easy for you. So this is completely optional. So this will differ from problem to problem. It's just your simplification skill. And now I have written the same term here. Just we are going to cross multiply. W minus I into Z plus 1 is equal to I into W plus I into Z minus 1. Okay, we are just going to multiply W into Z plus 1 minus I into Z plus 1. That's equal to, again, W into one more I is there outside, W into I into Z minus 1 plus, already we have one I and this I, so this will become I square into Z minus 1. Just we have multiplied, and from these two terms I am taking W common. These two tick marks I have taken W common, so this is the term. So Z plus 1 we have written as it is, I into Z minus 1, if it comes to the other side, negative sign will be there. So I'll push this term to the right hand side, and I square value is minus 1. So we have written this as it is minus 1 into z minus 1. If this minus comes to the side, this will become plus again. You got W in terms of Z. You remember what is the general format? W is equal to AZ plus B by CZ plus D. Correct? So I have to, after this step, I have to just bring it to the general format. That's the only task. Already completely Z is in one side and W is on the other side. Multiply with IZ plus I have written this, minus Z, minus of minus, plus 1. This minus and this minus plus. Similarly, denominator Z plus 1 as it is, minus I into Z, minus IZ, minus I into minus 1, plus I. We've got these two terms. Now, I'm going to take Z common from these, because AZ plus B by CZ plus D, right? This is what we want. So, this is what we get. If you take Z common from these two terms, Z into I minus 1 plus 1 plus I. Again Z common from these two terms. So 1 minus I by 1 plus 1 plus I. Now again this needs simplification. What I am going to do? Multiply and divide by 1 minus I. So that this term is too huge, right? So same as the previous one, the terms will automatically get simplified if you multiply this and divide by this. So 1 plus I into 1 minus I. So this will become 1 minus I square. Numerator also 1 minus I square. Just you are going to multiply with this term. So if you want, you can multiply like this, or you take the minus sign common. If you take minus sign common, this will become 1 minus I. So 1 minus I, the whole square formula you can use. Just I have multiplied. I into 1 I into minus I square, minus 1 into 1 minus 1, minus 1 into minus I plus I. That's it. So I have given more steps. This is a plus b, a minus b, a square minus b square, 1 square minus I square. What is I square value? I square value is minus 1. So you will get plus 2, and this if you simplify, again minus I square. So this will become plus 1, this and this will get cancelled. I will get only 2iz in the numerator. Similarly, minus 2iz in the denominator. So now if you see this, taking 2 common from the numerator and denominator, you get 1 plus iz by 1 minus iz. The same problem you can solve it just by substituting the values in W. Okay, we are going to solve the same problem in method 2. First we use cross ratio, right? Now we are just going to use the formula W is equal to AZ plus B by CZ plus D. What is your first? Z1 1 and W1 is I. So you are going to substitute in the place of Wi in the place of Z1. So this is first equation, cross multiply. So A plus B is equal to IC plus ID. So bring this to the other side, we will get negative sign. So A plus B is equal to IC plus ID, then A plus B minus IC minus ID is equal to 0. This is equation 1. Similarly, substitute Z is equal to I, W is equal to 0. So 0 is equal to A plus IB by C plus ID. If you do cross multiplication, 0 into anything will become 0. So you will get second equation, A plus IB 0. Third equation, minus 1, minus I you are substituting, you are getting this equation, minus A plus B is equal to minus C plus D into minus I. Okay, after cross multiplying, you are bringing it to the other side. So minus A plus B, and then here what you will get by multiplying minus C into minus I plus IC. Correct? If you bring it to the other side, minus IC. Then plus D into minus I minus ID. If you multiply and bring it to the other side, it will become plus ID 0. So you have got 3 equations, and you have to solve these 3 equations to find A, B, C, D. It looks very easy, but whether I have to add, whether I have to subtract, whether I have to multiply by I and add, all those things depends on problem. So it may vary from problem to problem. There is no permanent way to solve a 3 given solution. Okay, so now I am just trying to add 1 and 3 because minus di is there plus di is there. So if I add 1 and 3, I am getting an equation like this. Okay, similarly this minus di, I'll again explain, minus di and plus di will get cancelled. Minus IC and minus IC will become minus 2IC, and B plus B will become 2B. So 2b minus 2ic is equal to 0, which implies 2 into b minus ci is 0. 2 is not equal to 0, so b minus ci made it 0. So this is equation 4. So now what you are going to do is, this equation is also having two terms, a, b. There is no c. Here there is no a. So we got an equation with three unknowns. Okay. So ai plus 1b plus 0c. C is not there, you mention it 0. Again here second equation 0 is not there, so 0a plus 1b minus ic equal to 0. Now we will be using the rule of cross multiplication to find a, b and c. Remember by the method of determinants, a by. So first you are going to write the coefficients. What are the coefficients? 1, 0, 1, minus I. Then next minus b by, leaving b, leave this b and write down the coefficients. So what are the coefficients? I, 0, 0, minus I. So I have written this. Now leave c. What are the coefficients? C divided by, what is the first coefficient along with a? We have I, and then we have 1, and then next one 0, and then 1. So we have written this. Now you have to simplify. Yes, so you'll get a by minus I, just it is determinant, right? You have to just cross multiply. Here if you see minus I into 1, minus I, 1 into 0, 0, minus I minus 0. So we will get only minus I. Similarly minus I square we will get. Here I into 1. All the second term will become 0. So we are leaving this. Now if you see the same terms I have written the denominator, you just equate it to some constant k. So a is equal to minus ik, b is equal to minus k, c is equal to ik. So you got a, b, c. Now we are going to substitute this in equation 1 to get d in terms of k. So finally we got d as minus k. You have to substitute in this equation and take k common and cancel it. Okay. So ikz minus k by ikz minus k. So you are going to take common minus k. So 1 plus iz by 1 minus iz, you got the same equation. Now you got the answer as w is equal to 1 plus iz by 1 minus iz. You can check whether your answer is right or wrong by taking any one value. Say if I take z is equal to I, here your z2 value is I. What is the corresponding w2 value given in the question? 0. If you get that answer by substituting in this, then it means your answer is correct. Let's check here. 1 plus I into z. In the place of z I have replaced I. So numerator and denominator I have I square. I square value is minus 1. So numerator will become 1 minus 1. Denominator already minus sign is there, right? So it will become 1 plus 1. 0 by anything? 0. So it means your answer is correct. And already we have seen that how to find the fixed points. Just replace w by z and you will get the fixed points. Now if they ask us to find the image of mod z is equal to 1 under this bilinear transformation, how to proceed? Since they have given mod z less than 1, I have to write the same thing in terms of z. Then only it's easy for me to compare. Correct? So w is equal to 1 plus iz by 1 minus iz is the given transformation. Just I am cross multiplying. 1 plus iz is equal to w into 1 minus iz. We have written that. And here multiply w inside, w minus wiz. I am taking z common. So this minus iwz, if it comes to this side, plus iwz. So I have written iw plus, already we have I. We have taken z common from these two tick terms. Okay. Now leftover term is minus plus 1, if it comes to the other side, minus 1. Already we have w, so I have written that as it is. So w minus 1 by I plus iw. You can take I common. So w minus 1 by w plus 1. 1 by I is minus I. This minus you can take it inside. Okay. So minus of, yes, since you have taken minus inside, so w minus 1 will become 1 minus w and you will get plus I. So you have just rewritten z in terms of w. Why? Because in your question they asked what is the transformation under mod z less than 1. Modulus of z less than 1 means modulus of this will be less than 1, right? So modulus of I into modulus of 1 minus w by 1 plus w less than 1. Anyhow, this value is not going to be less than 1. So we are going to compare this only. If when we square it, anyhow, I square value and modulus, it will become plus. So this will not going to affect the result. So leftover term is modulus of 1 minus w the whole square less than modulus of 1 plus w the whole square. Okay. Now w is nothing but u plus iv, just substituting, segregating the real part and imaginary part. 1 minus u is the real part and minus iv is the imaginary part. Negative sign is there outside. What is the modulus of any complex function? Real part the whole square plus imaginary part the whole square. So why we have taken the square? Because it is square root of, since it is whole square, the square root is not there. Okay. Similarly, right hand side, 1 plus w, w is nothing but u plus iv, real part is 1 plus u, imaginary part is iv. Modulus of this is square root of, already we have square, right? So square root will not come. 1 plus u the whole square plus v square. And now you are going to simplify. A square plus b square minus 2ab. Here a square plus b square plus 2ab. Since we have 1 square plus u square on both the sides, that will get cancelled. V square also will get cancelled and you will get minus 2u less than plus 2u. So bring 2u to the other side. So I can say 0 less than 4u. Okay. It means u is greater than 0. Correct? 4u is greater than 0, which implies u is greater than 0. So this is the image of mod z is equal to 1 under the given transformation. So most probably they will just ask find the bilinear transformation, or they will ask find the fixed points, or they may ask like this, find the image of mod z less than 1. See this problem, it is done in method 2 only. We've got 3 equations. So we have done 1 plus 3, because it's like you have to see the equations and you have to decide whether you are going to add, you are going to subtract. And here 2 plus I into 3. Why we am multiplying by I only to the second equation? Because I want to cancel those particular terms. And further, if you see, the cross multiplication is too huge. So always than this method 2, method 1 is better if you are not good at solving equations and finding the unknown. So you can follow whichever method you feel convenient. Thank you.